Thank you and good afternoon to all of you. And thank you, Bhagwan sir. You have done very much big otherwise that it's very difficult to consume and listen this kind of the this one. Okay, anyway, thank you. So today we'll start the some discussion about the some study case studies about the industry 4.0, the industry that is we are saying it is a future trend. Okay, but basically if you are going to see it more in detail, that the future trend starts in industry 5.0. Now we are discussing about the industry 4.0. Okay, while we are learning about the industry 4.0, okay, now in the market, if you are going to just search it out, what is industry 4, 5.0, we will come to know what is the difference between these two. Okay, that points we will discuss during this session. Okay, so this one is the time span or the time view of we are going to have the discussions for this session one. Okay. So before Miss so far few of the lectures or the video of this one already I have attended, and in that I have already these topics were discussed about the IoTs, advanced robotics, artificial intelligence, cloud computing, cyber security, okay, and additive manufacturing, okay, and the AR and VR application of all those things in together, we can call it as the industry 4.0. And much of the focus in your earlier sessions, it has been done already on the IoT, the advanced robotics, and all those things. So these points that I'm thinking that no need to be and discuss it more in detail. Okay. So we'll move to the next one. Why the industry 4.0 drives competitive advantage? What are the advantages of this or the benefits we can say of this industry 4.0? This industry 4.0 gives us the more productivity and the efficiency, which gives us a positive impact on the profit side. Okay, and also the cost get optimizes. Why? Because we are putting or we are using the automation kind of the things. Okay, and the robotics obviously it is there. And uh, one of the, we can say the disadvantage, or there is a lot speaking that many of the people are going to lose their job because of this industry 4.0. But on the other way, or on the other hand, we can say that there are the more job opportunities are going to get created. Okay, and if you are going to see it as an if we are the all are the teaching professionals, okay, so when we are in teaching professionals, we have a lot of chance for doing the number of patents in this. If you are going to work with this industry 4.0 or the IoT kind of the tools or the different tools. Okay, just discussing point of view, I'm sharing my one of the thing that one of the patent that I have done it with the IoT kind of the thing, which is similar to that of the industry 4.0. Okay, and one more patent which is in the process right now, the documentation process, all those things were going on. And when we are going to discuss about this industry 4.0, it's different factors, okay, like the IoT and the advanced robotics, AI, all those things we can club them together and we can see it, how we can use it in our day-to-day life. Okay. Now in this one is the additive manufacturing. That additive manufacturing, now as if you are going to see our syllabus as per MHBT or university wide, all those things. Okay, this additive manufacturing nowadays, the meaning workshop at the school level, they are going on. But still, we are lacking behind in few of the universities or at the board level in this syllabus, we can say. Okay. So we need to overcome of all those things because it is not just like using a 3D printing machine and making the job. It is not only related kind of the thing. If you are going to get entered in the plastic, what are its different types, at what temperature we can make useful of the things. Again, the 3D metal printing, or many other things are going to get added to this one. And if you are going to talk about the AR and the VR system, okay, just 2 years back, also I am thinking that AR and VR might be the similar kind of the thing, but we know the actual reality and the virtual reality. Okay, so AR, VR, and the VR system, they are going to be the same. Okay, so we can say that the AR and the VR system, they are going to be the similar kind of the thing. So we need to overcome of all those things because it is not just like using a 3D printing machine and making the job. It is not only related kind of the thing. If you are going to get entered in the plastic, what are its different types, at what temperature we can make useful of the things. Again, the 3D metal printing, or many other things are going to get added to this one. And if you are going to talk about the AR and the VR system, okay, So again, I will put in one of the example. Nowadays, we have what the practical we perform in the welding shop. We burn many number of the electrodes and the workpiece. Students used to do the practice or the job. Okay, and again, we are making the engineers. We are developing the engineers, but these engineers are not going to work actually in the industry, right? We are not giving them the education to enhance their skill, but still we are using our electricity, the number of electrodes or the wastage, what they have done, the welding joint, all those things. Again, we are going to make it scrap. So all that is, we are making the scrap. If you are going to make use of the AR kind of the system in the building itself, okay, and these AR system are very much user friendly. Okay, just that will have that goggle kind of the thing and the electrode, every field that we are going to get it over there. Even if you are going to see it in 360 degree, the student will have the feel like that he is working in an industry kind of thing. So it is going to enhance the skill of the student also. They are going to realize it. Okay. And nowadays in the welding related industries or the education these systems, they are using this technique to enhance their skill. Okay. And the certification is valid in industries also. Okay. So these AR and VR kind of this. So all these are the tools in Industry 4.0. Okay. So there are a lot many advantages as compared to the disadvantages of this Industry 4.0. And the most important thing is the safety, which is mostly covered in this Industry 4.0. And if you're going to analyze the case studies of an any industry, which is Industry 4.0 is was saying, okay, in this one, these five steps that we need to cover it. So the first one is the context. We need to understand the business, okay, and the challenges or the environment, the frame, what kind of the business or the product they are going to make it. Okay, that we need to understand it properly, thoroughly. What are its parts or the component and all those things they are working on it. That is the context one. The second one is the technology stack. We need to identify, define, or find it out the digital tools and platforms using in their industry. Okay, digital tools means what? Okay, if we, any product life cycle, when we have to be define it, make it. So for right now, we are performing their life test. Okay, how many number of hand cycles that the product will run, or the bearing, or the shaft. What are the different stresses will develop? Actual experimentation that we need to perform. Okay, that is the conventional way of finding out the life of the product one. Okay, but nowadays we are dealing with the such kind of an the simulation software that we don't need to go for that. Okay, that is the technology stack. What the technology stack has that in that industry. The next one is the execution steps. We need to have the detailed action taken, okay, and how they have implemented the things, okay. That we need to find it out more in detail, okay, and how the product it was developed and how they are going to face the different problem, execution problem during making of that product, okay, and how they have come overcome of all these problems and outcome, measure the results and the benefits achieved from this execution. Is while they are going to have this technology stack and the execution steps, everything one outcome is we are going to measure what kind of the benefit, or we can say the productivity, how the productivity and the efficiency factors affected on their outcome one. Okay. And the lesson and transferability, extract the key learning applicable for other industry. Okay. There is not a such any blueprint that, or we cannot say it is defined path for to go for the industry 4.0. Industry 4.0, it is not only related to the mechanical things. It is related to all the fields, or we can say each and every place we can implement this industry 4.0 technique on. Okay. Now, the best example was given is of the digital twin one. Okay. So what is the digital twin? Digital twin is nothing but and the digital representation of an any physical product which is called as a digital twin. Okay. Here we are going to see when we are manufacturing any product or we are saying that we are we have to make that particular requires, let us say, 8 or 10 number of components, which we are going to assemble them together. And after that, they will have the assembly line. And after that, the machine or that product will work, something like kind of the things. So all those things, we need to define each and every product. Okay, the life of the product or the life cycle of the product, it starts from its design step, or the first step which defines the life is the design one. Okay, so digital twin, it also describes how to manufacture the product. Okay, designing the different designing tools that we have. Okay, in mechanical industry, we have the different designing tools. Okay, with the help of which having the mesh, or we can check what are the critical areas or the critical points where the stress concentration is more, and how we can minimize it by having the different options with the material, with some changes in the specifications. Okay, we can have, we can increase or optimize the chance as per the lifespan of that particular component, what we are going to design it, that we can define it. Okay, and the next one, how we this product will behave during its operation, that all those things. Okay, this simulation software, nowadays the cost of the simulation software is on very much on higher side. Okay, it is very much difficult for, and you can say the medium scale industry or the small scale industry to acquire or to have this kind of the software. But as an institute, when we are going to learn or when we are going to focus on this kind of the product or the industry, they are using all the simulation software to optimize their products. Okay, which ultimately goes to define the life of that product one during the operation service and the maintenance. Okay, during operation service and the maintenance, and it covers the whole life cycle of the product. Okay, before the product, the physical product come into the market or come into the actual reality, the product is digitally manufactured. Digitally manufactured means its image, its characteristics, its working at different temperature, at different working environment, how the product will behave. All those things were defined, or we can make uh, the life of the product, or we can define the life of the product, that one. Now in industry, in mechanical industry, if you are going to have the AGV, that is automated guided vehicle, nowadays all the jobs which are related for shifting or moving the things from store to the stock, or finish the product to the stock, and some raw material which is needed on the shop floor, all those things nowadays are handled by the AGVs. Now, this the success, okay, of this digital twin of this company is depends upon how interrelated of the different things working together. Okay, and like the design phase, the manufacturing phase, and the operation phase one. Okay, and the service and the maintenance phase. So whole life cycle or the product journey starts from design and it ends at the its service and the maintenance phase. So within these four, that is the design, manufacturing, operation, and the service industries, all those things, how they are interrelated or interconnected. Okay, once the design has been done, all the parameters were optimized, then the next process is the manufacturing one. So the manufacturing of the product, the way the involvement of the human in this industry was minimized. Okay, the manufacturing process, the steps, what kind of the raw material be required, what should be the depth of cut, what should be the feed. In terms of the mechanical things, I'm putting all the things it over here, but it is applicable to all the type of the industries when there is the manufacturing kind of the things. So all these manufacturing process were also defined. Okay, It is not like that only the backward mechanism. Feed forward mechanism is over there. Once the design was done, then it used or it feed forward sequence of manufacturing operation is defined in this one. After defining the sequence, the selection of the raw material, procurement of the raw material, okay, and the raw material when it will arrive, it will uh, start with the operating of the first job, second job, and third job. So it is the feed forward mechanism is over there. Okay. Till now, what we are working so far, that is Industry 3.0 feedback mechanism. Okay, again in the feedback, if you remember, open loop and the closed loop kind of the system we have studied in the CNC machine. Okay, from that journey, the engineering journey or study journey gets started. We never think about the feed forward mechanism, which we can see it in the Industry 4.0. Okay. So in the design, we can use the CAD related or the flow or the electric models simulation software to optimize and to get the this one, get the design optimized one. Manufacturing phase, we can simulate the manufacturability, create the feedback loop, and design an improvement. Okay, auto-generated the PLC code that also we can have available. In this one, we will have the accurate and high quality data capture essentials for reliable digital twin performance and insights one. Okay, and the next phase is the operating phase. So in this, optimize efficiency, reduce emissions and downtime, use simplified and the real-time models, and the maintenance service and the maintenance if you're going to see for this one. So the maintenance or breakdown kind of the maintenance things are not going to happen it earlier, and we'll have the good food feedback, which is in the continuous type of the feedback, what the values we are going to obtain it. Okay, and we'll have the large database. Now that large database and the analysis of this database and all those things, they are going to come into the industry 5.0, how this database can be used. Okay, in this one. The next one is the how this Rolls Royce, okay, one of the brand name in the automobile industry is the Rolls Royce one, okay, which gives the predictive maintenance. Okay, why these Rolls Royce are means they are related to the industry 4.0, because while they are going to make it manufacture it, okay, after that while they are going to provide the service to the customers one, okay, the Rolls Royce predictive maintenance is that it is that thing which is really appreciable how it works, okay, on which parameters it works. The engine which is used in this Rolls Royce, okay, either in the plane, okay, aeroplane, or in the, this cars also in automobile, okay. These engines are the smart engines one, okay. So each and every moment data they are going to have the transmission, okay. That data is stored one, okay. And nowadays the vehicles what we are going to see it in the market, they are going to become somewhat up to, so step by step they are going to become a smart one, okay. Now, initially, if you're going to have, just I'm giving a simple example. Initially, when we have the less pressure, tire pressure, okay, we need to check it. Okay, we need to get down from the vehicle, or we need to park our vehicle near the any station one where we can check the air pressure. If you're going to start our journey for a long distance, okay, we need to check all the things, whether the coolant or the oil, each and everything is up to the required level or not. Okay, but nowadays, all the sensors are available on our dashboard. Okay, because this the vehicle is going to become smart step by step. If the front side, left, rear side, okay, again in the front side, right wheel or the left wheel, rear side, left wheel or the right wheel, in which tire the pressure is low, that we can see it or check it on our dashboard itself. Okay, so because of this means day by day, step by step, we are developing or we are making our vehicles smart one. Okay, The other features which are we can say the parking or these kind of the things. Okay. Now we are also the India. We are though we are lagging very much behind of this roll size because it will take some more time, next 10 years at least, to go up to that level so that the common man will have such kind of the vehicles. Okay. But again, that is the sensor data collection. High fidelity sensors on engine captures and real time. And during this operation, the incidents or the accidents may happen because of the certain failure of a part all at a time. Okay, so it should not be like that. For that reason, this sensor will collect, and where this data is being stored one. So this data, each processing raw sensors data is filtered and compressed locally to reduce its size. And all this data, it needs to be have some kind of the storage one. Okay? That is the cloud analytics. Clean data streams into the cloud platform for comprehensive analysis. So whatever the data has been collected, okay, it is been stored and it is being analyzed. Okay, what kind of the analysis they are going to do it or perform on it. Okay. For an example, if any one of the engine who is going to continuously work, okay, for at least let's say 10 hours, okay, and it is going to have the stop for next 10 days, and in one of the engine who is going to work 1 hour every day and it is going to work continuously for 10 days. Okay, so what will be the change in the life of that? Though, if you're going to have the data for the 10 days, both the engines are going to work for the 10 hours only. But there is a difference in the condition of the oil or the coolant or the parts only. Okay, because one of the part or the component which is going to work continuously for 10 hours, and the second case, one of the component is going to work 1 hour every day. Okay, so that the data which is on the cloud, which is being get collected one, it needs to be analyzed one. Okay, that is the cloud analytics one. The next one, predictive model, estimate the component life and detect auto auto miles earlier. The parts or the we can say the breakdown maintenance. Okay, predictive maintenance is more important one. Before failure of any part in our mechanical things, what we always used to say that any mechanical component never fail without giving signals. Before failure, each and every mechanical part or that mechanical component gives certain kind of the signals. Okay. As in the maintenance engineer, the role of that maintenance engineer is to read these signals. Okay. But nowadays, the parts which are fixed in the aeroplane or in the automobile, in the vehicles, okay. So each and every time the mechanic or the person is not possible or is not feasible to have the look too much close to that the engine parts or the bearing of that engine one. Okay, I'm just giving an example of that bearing one. To have the look at these points, okay, and he will predict one. And for that purpose, we need to have these machine learning models, okay, so that these will detect the things automatically. And once these things will get detected, the digital twin integration, okay, so all those things, when these things are going to happen in actual life, okay, before going to make it actual, the digital twin integration needed over there in the industry one. Okay, so while before putting the things into reality, how the things we expect in reality, these things we need to convert it into the digital form. That is the digital twin integration one. Okay, and that is the maintenance scheduling. Inside this trigger, just-in-time maintenance and enhance the longevity to reduce the downtime of that one aeroplane one. Nowadays, we have just seen one of the incident was happened in Gujarat. Okay, one of the aeroplane get crashed and all those things. Okay, why these kind of the accidents were happening? After 1 week, we come to know that he has not turned on the fuel, this one fuel switch. He has not make it on. He forgot. Okay, because no one is going to do it intentionally, but he forgot to make it on, so that the fuel line supply get cut off, and that's why the plane could not take the take a takeoff. That causes the problem. So itself, if it has been already digitally twin integration system, okay, if you're going to have that case study for this one, is it possible that kind of the accident can be avoided, right? As it was not digitally twin integration of that the company or that industry or which is the plane manufacturing one. That's why this kind of the things, okay, may happen in future or in day-to-day life also. These things were happening. So, maintain high quality to secure, prevents, and ensure the trustworthy models. Okay? Rigorous model validation. These are the key lessons and the pitfalls. Validation, it trust. Okay? Deep domain expertise, isolated silos to foster integrated analytics and operational questions related to this one.
Hello.
Ah, yeah.
Sir, your screen is not visible.
Yes.
Screen not visible, sir. Your presentation is not showing.
Ah, yes, tell me. Okay, in that one now, which is not related to this industry 4.0, the industry 5.0. Nowadays, just few days back would be just I gone through one of the news. Okay, that one of the doctor from one place he has done the operation of the patient with the help of the AI and the robotics. Okay, that is one of the example of the industry 5.0. The major drawback, which was discussed, that the major drawback of the manpower or the job of the people were getting loose and it is not environmentally okay, that industry 4.0. Many of the points which are the disadvantage of this industry 4.0 were covered up. Okay, the disadvantage of this process were sorted out in this industry 5.0 one. Okay, among of this one, the job loss. Okay, the number of persons those who are going to lose the job. So they have kept the role of the human being in that part. Okay, and the best example is that the doctor is going to perform the activity in his own clinic at his place, and the patient was get operated at far distance from him. So that is one of the example of the industry 5.0. Okay, and what how we are going to how we have started to have the knowledge or the working with the industry 5.0, that we have the 3D printing lab in the first year student, that they are going to interact with the 3D printing machines, how the jobs can be prepared, kind of the things they are going to learn in their first semester itself only. The robotics lab is also there, and the robotics lab different clubs, the robotics club or the CNC club. Okay, again we are putting some more sessions for these interested students. Okay, so they are going to learn about the robotics. They are going to learn about the 3D printing. and the AR and the VR system also that we have. So that the student will have the interaction with these machines and the latest technologies, so that they will come up with some new ideas, some new kind of the product. It is not always like that. Industry 4.0 is going to reduce their job. Again, I'm going to say that we have a lot of opportunity in doing the patent in these fields. As we are the teaching professionals, we have enough time to go through the different products, different technologies, okay, and what is the need of the society or any product, how we can use this product or the IoT kind of the things or the cloud data, how it can resolve the issues, all those things, okay. When we are going to think over it, definitely we can make means many number of patents. Cannot say it again, but it must be in two digits. Number of patents can be done easily. If you are from the mechanical field or the electronics field, whatever it may be the field, okay? Because the industry 4.0 now it is introduction we are having, okay? And the first person who is going to learn and the think or about this one is the engineering professional. That means from the industry, they are working professionally over there. With the given task, they have certain limitations, I can say. With the given task, they have to work. But we have not given with any task. We have to just go through the study and we have to find out the problem. And no one has done that much work in Industry 4.0 with the patent related kind of the things. That's what I have observed. Yes, Bhagwan sir,
Yes, sir. Yes, sir.
any questions?
Dear participants, if you have any question, you may ask to Rajiv Shinde, sir.
Hello.
No participants have any question or doubt.
Sorry?
No participants have any question or doubt.
Okay, okay, no worries. Okay, we'll stop then. Should I finish it?
Conclude. Uh, Dear participants, if you have any question, please ask to the ask to Mr. Rajiv Shinde, sir, or you may type in chat box. And it's mic off करो please. Sir, I think no participants have any question or doubt. So, with your permission, shall I conclude this session?
Yeah, thank you.
Sir, thank you so much, Mr. Raju Shinde, sir, for delivering such an informative and thought-provoking session on case studies and future trends in Industry 4.0. Your insights into real-world industrial applications and upcoming trends have truly broadened our understanding of how Industry 4.0 is shaping the future of manufacturing and technology. On behalf of Mahavir Polytechnic and all the participants, I sincerely thank you for taking the time to share your knowledge and experience with us today. So, dear participants, please remember to submit your daily feedback and assignment through the uh, which will be shared on WhatsApp or we also share in chat box. So thank you everyone for your active participation throughout this session. We will now conclude this session and see you tomorrow morning at 11 a.m. So thank you so much. Thank you, sir.